Welcome to the class of discussion of dummy variable model once again. So, today what we will do, we will take another dummy variable model that actually we have discussed earlier in the context of Chow test. Do you remember that we were discussing structural break analysis in a time series data, particularly the savings income example what we are discussing in the context of US. The same example, same data set we will take here, and what we will do the same structural break analysis to using dummy variable model. Why this is so? Because dummy variable model will overcome the shortcomings of Chow test. And what are the shortcomings of Chow test? Because Chow test cannot tell us if there is any structural break, what is the source of that, right. So, what we will do? We will quickly recap the Chow test, the structural break using Chow test, and then we will come back to the dummy variable model and we will see how to estimate the same thing using a dummy. So, this is structural break analysis once again. So, what we are doing, we were in the context of Chow test, using Chow test, so we had some 1970 to 1995 data on saving and income, and then in between we assume that in 1982 there was a structural break, because that was the time US economy was suffering from the peacetime recession, right, peacetime recession. So, what we did actually, we first we ran 3 regression, one for the time period 1970 to 1981. So, that was y t equals to alpha plus beta x t plus u t. This is for 1970 to 1981, and then another one for y t equals to, let us say, some alpha 0 plus beta 1 x t plus, let us say, this is u 1 t and this is u 2 t. This is for 1982 to 1995. Okay. So, these are the unrestricted model, and the restricted model was y t equals to y t equals to some lambda 0 plus lambda 1 x t plus u t. This is for the entire period 1970 to 1995. Okay. So, one for the pre-recession, another for post-recession, and the third regression is for the entire period, and we are checking the stability analysis, whether the parameters alpha equals to alpha 0 equals to lambda 0 or beta equals to beta 1 equals to lambda 1, that is what we are testing. Okay. Now, these notations might be different. Earlier I might have used some other notation. So, please be careful about the notation, do not get misguided. So, I might be using different notation at different point of time. So, basically the idea is same. What we are doing, that we were testing alpha equals to alpha 0 plus equals to lambda 0, and then beta equals to beta 1 equals to lambda 1. This is the restriction what we are testing. Okay. All right, and this what we are using F test, F statistic actually. How that is defined? If you recall, first we say that RSS from the restricted model. What is the restricted model? This one is the restricted model. When I am specifying one single equation for the entire period, that is our restricted model. Okay, that is our restricted model, and then RSS UR divided by its degrees of freedom, and this is RSS UR divided by its degrees of freedom. This is, let us say, degrees of freedom. I am writing degrees of freedom only, and this is also by degrees of freedom. Okay. And if you recall, what is the degrees of freedom for RSS R minus RSS UR? Because that is RSS R, what is the degrees of freedom? N1 minus the restricted model, that means N minus the entire period N minus 2k, sorry N minus k, N minus k. And RSS UR, how you are getting RSS UR? RSS UR was N1 minus k plus N2 minus k. So, it was N1 plus N2 minus 2k. Okay. And this is N minus k. So, this is basically N1 plus N2 equals to N. So, I can write N minus 2k. So, RSS R minus RSS UR when you are doing. So, RSS R minus RSS UR equals to N minus k minus N plus 2k equals to k. So, degrees of freedom for the numerator equals to k. And what is the degrees of freedom for this RSS UR, which is N1 plus N2 minus 2k. Okay. N1 plus N2 minus 2k, because there are two unrestricted model, right. So, now what you can do, this follows the F statistic with degrees of freedom k for the numerator and N1 plus N2 minus 2k for the denominator. So, that means here it is 2 and 22. N1 plus N2 equals to 26. There are total 26 periods of time, and 2k means 2 into 2, 4. So, 26 minus 4, 22. This follows F distribution with 2 and 22 degrees of freedom. So, this is the Chow test what we have discussed already. So, we will quickly estimate the two models, and what we will do, we will just go to the data set once again. This is our okay. So, now what we will do, we will estimate reg yt and then xt, and we will first estimate for the first 12 observation 1970 to 1981, there are total 12 observation, okay, total 12 observation. And the second regression is reg yt then xt in 13/26, okay, put enter, and then another for the entire period yt xt, okay, this is what. So, now you have to collect the RSS from all these models and calculate the F statistic. So, from the restricted model, RSS is 23,248.3. So, 20, if you look at this is actually, if you look at for this formula RSSR is 20. So, from this what I can say that this is 23,248.3 minus 23,248.3 minus what you have to do, you have to take these two RSS, these two RSS. 10,005 point, first one is this 1,785. So, basically, so I will calculate this in an Excel sheet, that would be easier, that would be easier for you to understand. So, what I will do, I will just close this, and I will open an Excel sheet. This equals to 23,248, I think 23,248, 248.3 minus you have 10,005, 10,005.2214 plus the other one is 1,785.03. This is your RSSR minus RSSUR. Okay, RSSR minus RSSUR, and this you have to divide by RSSUR, which is unrestricted, which is again equals to 1785.03 plus 10,005 .2214. Okay. So, this would become so the numerator, this you have to this divided by 2 equals to this, and here it is RSSUR, you have to divide by 22 center. Now, this divided by this, some 10.69, that is your F value. 10.69. Okay. So, ultimately your F value is, if you put all this, I am not doing all this again. So, this would become, after putting the numerical values for RSSR, RSSUR divided by K, and again entire thing divided by RSSUR divided by degrees of freedom, what you will get? The value is 10.69. 10.69. So, this is your calculated F, calculated F, calculated F. Okay. Now, if you compare this calculated F, okay, with the tabulated F at 5%, 10% and 1% level of significance, then what will get? Your values are, what will happen? Your values are like, if you compare the tabulated value from the F table, what you will get is at 22 degrees of freedom, the tabulated F is tabulated F at 2 and 22 degrees of freedom equals to 5%, it is 3.44 at 5% equals to 5.72 at 1%. So, that means 10.69 it is greater than 5.72 as well as it is greater than 3.44. Okay. So, your calculated value is actually greater than the tabulated value, and then what we will do, if the calculated value is greater than the tabulated value, so we have to reject our null hypothesis. And what is our null hypothesis? That there is no structural break, that is rejected. And if you reject the null hypothesis, so null hypothesis is this actually. The restriction what we have imposed, that is actually our null hypothesis, because if these conditions are satisfied, that means there is no structural break. Pre and post recession period can be modeled by one single equation. So, both the intercept and the slope coefficients are same. So, this is rejected, no structural break is actually rejected, it is rejected. And then what we said, when this is rejected, that means basically, that means Chow test is indicating 3 situations. So, here it is income, and here it is saving. Okay, saving. So, this is, let us say 1970 to 1981, and this is 1982 to 1995. This is case 1. Okay. So, in this case, post recession period, the slope is same, but the intercept is different. In this case, income, saving, so this is 1970 to 1990, 1981, this is 1982 to 1995. So, intercept is same, but the slope is different, that is case 2, and this is case 3, income, and saving. So, it is 1970 to 1981, this is 1982 to 1995. So, post recession period both slope and intercept are different. This is case 3 and this is actually case 4, saving, and this is income. So, these basically indicate these basically indicate 1970 to 81, also 1982 to 1995. For both the period, neither the slope nor the intercept is different. So, that means this is called concurrent relationship. So, both the time periods can be specified by one single equation. So, Chow test can tell you that this case 4 is actually rejected. So, we are eliminating case 4. There are differences in the two time periods, saving income relationship, but we do not know which among these 3 are actually the relevant for this particular data set. So, that means the difference in saving income relationship is coming due to intercept or slope or both, that we do not know. And here comes the dummy variable model handy. Now, we will see how to do the same analysis using a dummy variable model. So, let us first try to construct the model. Let us say that this is our yt equals to alpha plus beta 1 xt plus beta 2 dt plus beta 3 xt dt plus ut. This is our model, and how we have defined dt? dt equals to 1 if the period is 1970 to 1981, 0 otherwise. This is dt equals to 1 if the time period is 1982 to 1995 and 0 otherwise. Because when we say that the crisis or recession, so presence of recession, when the impact of recession is present, that we are denoting by 1, because the dummy variable generally we say that presence of the attribute is 1 and absence is 0. So, post recession period, that is 1 and 0 otherwise. So, this is how we have defined the dummy variable. So, now again here what is yt? Yt is your actually savings and xt is actually income, and if you take expectation of yt given dt equals to 1 and xt equals to alpha plus beta 2 and then plus you have beta 1 xt, here also you will get beta 3 xt. So, I am adding the two coefficients and then I am writing xt. So, that means for the period 1982 to 1985, this is my saving income relationship with slope intercept equals to this and slope equals to this. This is for the period 1982 to 1995. post recession period saving income relationship is defined as expectation of yt given dt equals to 1 equals to alpha plus beta 2 plus beta 1 plus beta 3 xt. So, that means this is the intercept and this is the slope. And pre-recession period, how it is defined? Expectation of yt given dt equals to 0 xt equals to alpha. So, this will vanish alpha plus beta 1 xt, beta 1 xt. So, this is for the period 1970 to 1981, okay, 1981.